Hi friends, I am Narendra Kumar. I have 12 years of experience in IT industry. Out of that 8 years I have been working in data engineering field. I have also completed these certifications related to Databricks and Microsoft, and I take interviews on a regular basis for data engineers and senior data engineers. In this video I will be covering the commonly question that I ask related to Apache Spark and whatever like other interviewers also that they ask. I will be explaining in detail which all questions we ask, how we are expecting you to answer those questions, and what mistakes people commonly make while answering those questions. And if you want to plan a mock interview with me, the link is in the description. So let's get started. So I will start with my favorite question, which is like broadcast join. Spark architecture is also there, but that will come later. So first of all, I ask please explain me broadcast join, and the common answer anyway, normally everybody is aware that whenever we have a small data frame, so that gets copied into all the workers in their memory, and then the larger data sets that gets divided into all the nodes, and that's how the join happens. So the follow-up question I ask, right, it is like when we say it is there in the memory, so what is that memory and where exactly it gets stored? So the answer to that, it lies in the Spark architecture. So the memory where that broadcasted data gets stored, it is the worker node RAM. So like we have our laptop RAM, like that we have these workers, they also have a CPU and RAM. So it gets copied into their RAM memory. So for example, this driver node, it will broadcast that small data into the memory of those workers, and those workers will use that data and then join with the larger data frame partitions, which are separated into different worker nodes. So that's how it works. And next follow-up question that comes on this, it is like when we are saying the small data frame or data set, how small shall it be, or how, like, what is there any limit how much we can use for broadcasting? So by default, the limit for using broadcasting, it is 10 MB. So if our data it is greater than 10 MB, by default it will not broadcast that, and we can control that limit. Let's see how. So in Spark, like we have this property spark.sql.auto broadcast join threshold. Its default value, it is 10 MB, and that's how it uses like 10 MB of data, like until that it used for broadcasting. But we can increase it. To increase it, we set this property like this. Let's say here I am setting it to 1 GB. In this case, it will be able to broadcast up to 1 GB of data. So that is how like we control how much data can be used for broadcasting, but we be careful while using it. This size, it shall be less than the available memory of the each and every executors. So that's how we control it. And the next question comes about broadcasting. It is how to use it. So some people, they get confused, like when we say how to use it, what exactly they mean. So simply we don't need to do anything specific by default to use it. If the smaller data set, it is within this size limit, then automatically Spark will do the broadcasting. And the next question comes is like, how can we know when we ran our job whether actually it used the broadcasting or not? So that is where this explain command comes into picture. So in PySpark and Spark SQL both, we have this explain command. If we explain the join operation, then here we can see what type of join is being used. So here we can see it is using the broadcast hash join by default, and we can see the same thing in Spark UI as well. There also it will show the broadcast hash join. If we will go to the in the UI to the job and stage that used for this broadcasting or this join. And along with this one way, there is one more thing we can set it up about broadcasting. So by default, Spark is now very intelligent to use broadcasting, but due to some reason, if it is not using, then we can give it hint like this. So in terms of SQL also, we can give it a broadcast hint like use broadcasting for the salary dataset. And similarly in PySpark also we can provide it hint. But again, this is a hint. Spark will use this hint if it likes, and it can ignore it also. It is not mandatory that it will still use it. So these are all the things we ask about broadcasting. Now I think you got some idea, right? How much deeper we can go. So these things confirm like theoretically how much aware is the candidate, and practically how much the candidate has used it, or does he really know like how to really use broadcast join or not. Now the next question comes like, if both the data sets are large, so obviously broadcast join cannot be used, then what type of join will be used? And the answer to this one, it is like it will be shuffle hash join in that case. So if both the data sets are big, like relation 1 and relation 2 in this case, so both of them will be partitioned and their chunks will be sent to each of the worker node. And while doing the join, it will have to do shuffling, because let's say if we have some joining key, and for that key the values, let's say 1, 2, 3, all common values will not be in a single executor. So first it will bring the common values into different executors, and then it will be able to join them. So the values will be going here and there, and that's where this shuffling will happen. And this shuffling, it will not be happening in case of broadcast join, because the smaller data frame or the data set, its complete copy is available in all the worker or executor nodes. So the larger chunk or larger data frame, it will use this complete copy and do this join here. Similarly, it will join here. Like this, the data is not shuffling, so it will be very fast in case of smaller data sets. Now as we are done with my favorite question, so next let's get started with the other question. So like, what exactly is Spark and why it is so famous that it is being used everywhere? So the answer lies is like Spark, it is a open source framework or like compute which is used for parallel processing of data, and it has multi-language libraries. So as we know, like Spark, it is a unified platform. It supports batch processing, stream processing, machine learning, and graph processing all into one. And before Spark, Hive and Hadoop were there, but Spark, it was like 100 times faster than those. And how it achieved that was due to its in-memory processing. So if it has multiple stages, so the intermediate results, it do not store them on the disk. It keeps them in the memory, and it uses from the memory to the next stage. That's why it is so much fast. And the next question is, what all languages are supported with Spark? So the answer is here. These are Scala, SQL, Python, Java, and R. These are the main programming. And some like other companies, they provide some other like custom languages as well. But by default, these are the core languages which are supported. And then I asked the question like, in which language the core Spark itself is written? So a lot of people, they think it is Python, or they don't know the answer. But the right answer, it is that Spark itself, it is written in Scala, not in Python or PySpark. Why it is written that way? Because like when it comes to actually executing the code or transforming any data, so Java is very fast. So they wanted to use Java. And Python, why everybody is using? Because it is very easy to write, easy to understand. That is where Scala was invented, that it combines the properties of Python and Java. In Scala, we write the code in a way we write in Python, but when we execute it, it internally gets converted to Java bytecode, and actually the Java code runs on the executors, the JVM code basically we call it. So JVM bytecode. So that is why Spark itself, it is the core part of it. It is written in Scala, and that gets converted to Java, and the JVM bytecode, that is something gets executed on executors. And all these other languages, these are wrapper on top of these. So if we write our code in PySpark, so that is also a question I ask, like if it is the Java code that is being executed, then what happens to the PySpark code that we write? So that PySpark code, whatever we actually write, that first gets converted to Java bytecode, and actually on the executors it is always Java bytecode that gets executed. There is no Python or PySpark code there. Next comes everybody's favorite question, which is the Spark architecture. So everybody asks it, right? Like, explain me Spark architecture. So how we shall explain is, like, Spark, it follows the master-slave architecture, and it has a driver node where we submit our code. So the code wherever we are writing, so that can be a separate node also, which can be a client node. So client will send the code to driver node, and within the driver, the Spark context object is created that is used to interact with the Spark libraries, and that is what takes care of distributing the data and everything. And this driver, it connects, so it compiles all the code, and when it needs the actual executors to execute the code, so it goes to a cluster manager. So Spark itself has a standalone cluster manager itself, and sometimes other cluster managers are also used, like Mesos and others. So the cluster manager, it will provide the address or location of the worker nodes, and then driver will send the code and location of data to the worker nodes. On the worker nodes, it will spin up the executors, and the executors will actually run the transformation or whatever operation we want to do, and the results will either be written to the storage or tables by the worker nodes, or the results will send back to the drivers. So in summary, like we can say, like, Spark, it follows the driver worker architecture, and the driver takes care of all the planning, all the distribution of the data. In workers, they just take care of the execution of the actual code on some partition of the data. That's how simply we can explain it. Our next question comes like, what are the different deployment modes which can be used with Spark? So here are the 3 deployment modes. In local mode, it is used for very like a local or minor testing, wherein client, driver, and all the executors, they run on the single machine. So that is like a local mode. Like if I run Spark in my own laptop, that's where I'm running the local mode. And whenever we have a cluster, so that's where we have 2 options, like client mode and cluster mode. In client mode, the client and the driver, they run on a single node or single machine, and the executors, they run on separate machine. So that is how like the client mode works. And in cluster mode, the difference is in terms of driver. So client and driver, they do not run on the same machine, but the driver itself, it is run on one of the machines in the cluster wherever the executors are running. So that is what is cluster mode. So simply saying, if all the things like client, driver, executors are in single node, it is local. If client and driver are together, executors are on cluster, it is client mode. And if only client is separate, client is basically wherever we are writing the code. And after submission of the code, if drivers and executors, they run on separate machine, it is cluster mode. Next, let's cover some of the key terms that are asked in Spark interviews, like what is an RDD? So RDD, it is a immutable distributed collection of data that can be processed parallelly across a cluster. So this is a standard definition. What really it means is like it is like a resilient distributed data set. So resilient means like it is error free. Distributed means it can be parallelly processed, and data set means data set. So it is like, let's say we have thousands of files in some particular location, and on top of that location it creates some kind of mapping, like that mapping is called RDD, and that mapping can be sent to as different partitions to different workers, so that they can process that data separately, independently, and if any of the data it is lost, they have the mapping, they can go back and fetch that data again. And data frame, it is like it is again a distributed collection of data, but it is like organized in terms of columns and rows, like a relational table. So data frames, those are built on top of RDD. So RDD, it simply means like mapping to those files, and then it provides some distributed manner. But data frame, they also embed the structure on top of those files. When I say structure, like the columns and rows, that's where data frames comes into picture. And partition, it is like a logical chunk of data in a RDD or data frame, which can be processed parallelly and independently. So let's say we have 1000 files in our source location, and if we create a RDD or data frame, so there can be 100 partitions, there can be 50 partitions. These can be anything depending on our resources. But what it really means is like single partition, if it holds mapping to those 5 files, so those files will go to a single executor, and that's how the data will be processed parallelly. Next, what is a transformation and what is an action? So this is again very important question. So transformation, it is like whatever operation we perform on top of like any RDD or data frame, and those real operations that we define, those are called as transformation. And transformations, they do not trigger the job. That is just a definition that is stored while we are doing it. For example, if we have mentioned these operations like filter, union, join, sort, or distinct. So if we, for example, mention filter, let's say where age is greater than 30, so it will not immediately filter out the data. It will store that mapping or that code, that whenever it will need to execute the code, it will need to filter out that data. So that way, for all the transformations, it will keep creating a mapping of whatever operations we are doing. So those are called as operations. So basically, these are like the operation which create new RDD or data frame without actually executing the code immediately. That is the standard definition we can use. And action, those are the operation that triggers the executions and then return the results to driver or writes them out. So the action is the operation that actually triggers the Spark job. So if we, for example, write these operations like show or count or write. So in case of show or count, it will show the data into the user. In case of count, it will show the count. In case of write, it will write the data to output table or output location. So this is the real action. And whenever we define the action, that is when the code actually starts executing. Without this, the code never gets executed. And until we are keeping defined transformation, and then only in case of action it gets executed, this concept, it is called as lazy evaluation. So what lazy evaluation means, is that whenever Spark it is lazy, and whenever it needs to provide the output, then only it will take care of the inputs and transformations. Otherwise, it will not do anything. It will lazily sit and just keep understanding what we are instructing it in terms of code. Whenever we are asking for an output, like show me the data, show me the count, or write the data, that is when on an action it will do all the operation. So this concept, it is called as lazy evaluation. The next question, it is about what is narrow and wide transformation, or what are the two types of two categories of the transformation. So the two types are narrow and wide transformation. In case of narrow transformation, the definition is each input partition will contribute to only one output partition. So it is like one input, one output. That's how we can say. So in case of filter or union, so in case of narrow transformation, we can get same number of partitions, or we can get the less number of partitions as well. So for example, in case of filter, if from each of the partition, if all the partitions had some data, then those filtered data will be available in equal number of partitions. And let's say if in one of the partition the filter data is not there based on that condition, so that partition will not be there in the output. Or in case of union, the partitions can be again combined and single partitions can be formed. So like that, the partitions can be same, or those can decrease. Those will never increase, and there will be no shuffling operation, because within the partition we don't need to share any information. It is always one input, one output. But in case of wide transformation, each input partition will contribute to more than one output partition. So this is a typo. It is not only one, it is more than one. So for example, like in case of join, sort, or distinct, let's say if we have some input partitions, let's say 3 partitions, and we are doing some join operation. So in case of join, all the partition will shuffle the data between each other, like we were discussing about in the shuffle hash join. So that shuffling will be there, and after shuffling, again the new partitions will be created. So there is no guarantee that each partition will contribute to only one output. In this case, let's say this partition, it is contributing to these 2 output partition. In this case, this is contributing to 1, 2, and 3 partitions. So like that. And in case of wide transformation, the number of output partitions, these can be decreased, these can increase, or these can remain same. There is no condition there, because depending on the operation, anything can be there. And that is where many people, they think that in case of wide, it means like because it is wide, number of partitions will always increase. It is not like that. It can be anything, like increase, decrease, or remain the same. And in case of narrow, it will never increase. It will be same or less. So the next question, it is like what are the different write modes which are available in Spark? So this is also a common question, and this one I would say 80% of the candidate, they know it. It is a very common. So these are the different write modes which are there, and by default it is error if exists mode, and it will throw an error if the target location it is already there. And in case of overwrite, it will overwrite the complete data in the target with the new data. In case of append, it will append the new data. It will keep the existing data, it will not touch it, but it will just append the new data into the target location or the target table. And in case of ignore, if the data or file they already exist in the target location, it will do nothing. It will simply ignore the operation. So this is almost never used. I have never used. These are the most common used, like overwrite and append modes. And the next question I ask, it is similar to write modes, what are the read modes which are available in Spark? And about the read modes, I would say 80% of the candidates, they don't know what is a read mode. If you know, you are already in top 20, I can say. And another question about read mode, it is same like how to handle corrupted records in Spark. So the answer to both of these, it is same. So here we can see that these are the read modes which are available in Spark, and these also can handle corrupted data. So by default it is permissive mode in Spark, even if we are not specifying anything. And if we get any corrupted data, so then what it will do is it will not write the data into those rows, but it will create a new column with this name _corrupt_record, and that is what permissive mode will do by default. And in case of the other modes that we can specify are fail fast and drop malformed. In case of fail fast, if it encounters any problematic or corrupted data, in that case it will immediately throw an error that data is corrupted and it will fail the job. And in case of drop malformed, it will kind of like simply drop the malformed record or corrupted records, and it will not load that. It will kind of ignore the data. It will not load, it will not create a new column, nothing. It will simply only ignore the corrupted data and do nothing with the it will load only the right data. So this mode, it is almost never used because we want the corrupted data also to be loaded maybe in separate column or separate table, but we don't want to silently ignore it. That's the reason you always use permissive mode, which is default also. And either we can use these read modes, or there is another option also which is used for which is like an option where we specify like bad records path as an option. And when we specify this option, what it will do is the correct data it will load into the target table or location, and not the corrupt data, the correct data it will write to the target location, and the corrupt data which is it is malformed or it has some problems, that data it will write into a separate location itself that we specify using this option. So in that case, like even for all the tables we can specify a common bad records path also. So that is how this one is used. So these concepts, these are really important to answer and to understand as well. And in case you want to see a demo or understand these in more depth, then that is there in my other tutorial video. You can check it out. The next question, it is about what is repartitioning or what is coalesce and what is the difference between these two. So the common answer that people already know, most of them, like repartition, it can be used to decrease or increase the number of partitions, wherein coalesce it is used only to decrease the number of partitions. So but what commonly they don't know is if we have to decrease the partitions, then shall we use coalesce or repartition, or what exactly does a coalesce do that it is faster as compared to repartition when we are decreasing the number of partition. So the answer, it lies how internally they work. In case of repartition, it will be complete shuffling of the data. So let's say input partition, whatever it is, output partition, even if we specify 2 here, so from each of the partition the data will be shuffled again, and the target partitions will be created equally new partition, whether it is more or less. In case of coalesce, it will not shuffle the data, it will combine some of the partitions. Let's say if I have specified 2 input are 4, so these 2 it will combine and create a new partition. So it don't have to do any shuffling. And in this case, let's say if I had specified output partitions as 3, so maybe 2 it will create 1 to 1 and other 2 it will combine. So that way the output partitions, even though it will be fast and it will reduce the number, but the output partition, those may be uneven distributed, because it is combining multiple input partitions, and it may combine multiple into one and other may be single depending on that number. So the data may be uneven, but depending on our use case, we shall try both, we shall compare their performance, and then we shall decide which one is best for our use case. So next I will explain the questions about Spark execution planning. So here the questions can come like, what is a catalyst optimizer, what is unresolved and resolved logical plans in Spark, how does Spark decide internally step by step how it will execute the code. And my favorite question is if I do a select column 1 column 2 from the table and that column is not there in the table, then at what step it will fail, or will the code will be failed by driver itself, or but it will throw the error while executing the code on executors. So you will get the answer of all these things based on this explanation. So let's say if we have our PySpark or SQL code, so that code, whenever we submit the code, it first gets converted to unresolved logical plan. So it is like a logical plan, like this is step 1, this is step 2, step 3. It is unresolved means like so far it has not checked whether the table or column really exists or not. So it has just captured the steps that we have defined. So that is unresolved logical plan. After that, it will verify all the columns and tables that we have specified in the catalog. The catalog, it can be Unity catalog if we are running in Databricks, or it can be Hive catalog if it is Core Spark, or it can be something else also. So it will check whether all the tables and columns they really exist, and from those tables and columns it will also fetch the statistical information, like how many total counts are there, how many distinct values are there, what is the min max and those kind of values. So it will fetch those. And now because it knows like all the tables and columns exist, so this new plan, it is called as resolved logical plan. And then this resolved logical plan, it is passed through the catalyst optimizer, which optimizes this plan and create optimized logical plan. So catalyst optimizer, it is a set of rules defined in Spark. Based on those rules, it can reorganize the code so that it works in a more optimized way. And the most common example of this reorganization, it is predicate push down. So the term, it is fancy, like what is a predicate push down, but what it means is like a filter. So if we are joining two tables and then we apply a filter on one of the column, so it will push that filter first to the table. So it will apply the filter first, then it will do the join. So this pushing the filter above so that it fetches only the relevant data, this is called as a predicate push down. And this is one example like I did. Similarly, there are different rules specified in Catalyst Optimizer. We can even extend Catalyst Optimizer and specify our own rules if we want, but in 12 years I have never found a need to do that, but the option, it is there. So passing through all those rules, it creates this optimized logical plan. And from this optimized logical plan, it will create different physical plans. So by physical plans, what it means is like it will create different options how exactly it is going to execute the code on the executors, like how many stages it shall create, how many jobs it shall create, and what type of join it shall use in each of the stage. So different options it create first, and for those options, the statistical information that it has fetched, like from the table, like the count or distinct or min max values, so that information it will use, and it will pass all these things to the cost model, and it will also specify like what is the current compute that is available to it. And then the cost model, it will decide like what is the cost of what will be the cost of execution for each of the physical plan, and whatever will be the cheapest cost plan, so that will be selected as a best physical plan, and that will be the final plan. And based on that plan, it will send the code and the location of the data, or the actual data also maybe, to the executors on the cluster. So that's where the code will actually gets executed. So this is how we can explain it end to end, and I hope you got all the questions that I had mentioned. And one question that I mentioned, right, like where it will fail. So if we specify, let's say select column 1 from table 1, so because first it is creating resolved logical plan, it will not fail here. At this step, when it is checking whether that column is there in the table or not, it will not find that column in the table, and this is where at this step the code will fail. And because until the best physical plan, all these steps are running in driver only, So the code, it will fail in the driver itself, we will get the error. The job, it will not even start on the executors. Next, like we will cover if somebody asks like what is a job, stage, task and what is a DAG in Spark. So how shall we answer those? So the code that we are writing in PySpark or like whatever language, SQL or Scala. So whatever code we are writing or whatever we are trying to do operations, so that code, it is called as Spark application. So we have some use case that we are trying to do, right? Let's say we are finding a trend of views over the period of time or whatever it is. So that code, it is called as Spark application. And whenever we are executing that code, so it will run one or more jobs to execute the code. So for each application, we can have one or more than one job, and the job will be doing like different operation, and each job will be submitted to Spark separately. And for each of the submitted job, there can be like multiple stages. So each of the job, it will be broken down into multiple stages. So stages can be, let's say, in stage 1 it can filter out the data, in stage 2 it can join the data, in stage 3 it can aggregate the data and then write it. So like that, logically it breaks down the entire operation into multiple stages. And for each of the stage, it will create multiple tasks to do the operation in parallel. So for example, if we want to apply some filter on the data, so if we have, let's say, 10,000 files, so those files, partitions will be created, and for each partition the filter will be applied on a separate executor. So applying that filter on one executor, that is one task. Similarly, on each and every other executor, the same filter will be applied. So each executor will run different tasks on similar task but on different data. So that is how for each of the stages multiple tasks are created. Tasks are normally like for each stage, those are identical in nature. It is just they run parallelly and on different set of data. And because it has all this hierarchy, so to maintain this hierarchy and to keep track of it internally, it create a kind of graph. So like that graph, it is called as directed acyclic graph. And in this graph, it store the information like for each job, like what is the which all jobs are there for each job, how many stages were there, and then how many tasks were created. So let's understand this through an actual Spark UI also. So here is my Spark UI, and in this one we can see that in this one these are the 4 jobs completed. When I joined 2 tables, so it created 4 jobs for that one, and for each job, if I click it, there are multiple stages. So it had created these 3 stages, 2 it decided to skip them, and 1 was completed. So if I go inside the stage, I can then see like how many tasks were completed. So for this one, it ran 200 tasks. So these are the detail for each and every task that it ran. So that is how these things are interlinked, like job, stage and task. And for each of the stage, it will create the DAG, directed acyclic graph, like this. So whatever join operation it is doing or other operations it is doing, so this is how actually it creates the DAG diagram in Spark also. The next question, it is about Spark UI only. So what we ask is like what are the things that we can check in Spark UI, or what are the things that you have actually found useful in Spark UI. So the answer to this question, it confirms like how much hands-on you have done, or practically how you have used Spark UI for doing something useful. So as we can see in the Spark UI, so we get to know like these job, stages and task related information, which is everybody will know. But if we go to the DAG diagram of any job, so that is where like it provides lot of useful information as well, like which kind of operation is being performed, and it also provides like how many rows were read and written at each and every stage. So that kind of information it is provided here. And for each of the tasks also we can see how much time it took, and if like some tasks are taking more time, some are taking less time, then that is something we can track here, like what is the minimum task time for all these tasks, what is maximum. If there is so much difference, then that means data skewness is there, which we can handle using sorting techniques. And we can also like understand like in terms of storage, like whatever cache we are doing the data frame or table, so that also it is shown here, like which type of storage level is used, how many partitions are created for that cached data frame, and how much percentage it is cached, size after caching on memory and on disk. And in environment variables we can see all the default properties which are set, and all the custom properties also that we set at the start, those we can notice here. In executors we can see which all executors are currently running, which are down, all these things we can track here. And in terms of SQL, whatever SQL operation we are running, so those we can see here. And in terms of SQL we get so much more information as well, like in case of this DAG, like I was talking about, so at each and every stage we get to know like what were input rows, after applying the filter how many rows we got, how much data was read, how much was written, like what operation it is doing at each stage, what kind of join it is using. So all these things we can check it out here. So if we tell these things, so that is normally enough and gives confidence that yes, you have worked on this Spark UI. Now the next question, it is about like what is the difference between cache and persist, or like where shall we use cache in general, and which one of these two we shall use, what are the storage levels that we can use with persist. So the answer to this is like in case if we want to use the same data frame multiple times, let's say one time if we want to join it, one time we want to aggregate it, one time we want to simply write it. So if same thing is being used more than once, then we instead of storing the final, instead of recomputing it every time, we store its data or its computed result into a memory or on the disk. That is where cache and persist comes into picture, so that like the same stored data can be reused multiple times. Also in case of very complex transformations which has so many steps, so sometimes storing the data in between, it will break those bigger transformation into different stages or different like steps. So there also we use it practically sometimes. So that is the purpose of using cache and persist. Now to store that data, there can be different options. So if we want to store the data into memory of the executors only, so that is where we use the cache. And if the memory is not enough and it can all the data it cannot fit it there, that is where we use persist. And in persist we can specify different storage level options as well. So let's understand these in more detail. So if I'm using the cache, for example, by default, and if I go to Spark UI, so in the storage section we will see how much it is stored, and currently we can see like it has stored it in the disk memory. It is deserialized and it is one replica is there of the data. It is stored in these many partitions. It is 100% cached, and this is the size. So in case of cache, if the memory is not enough, it will not be stored 100%. It will store some of it, and rest of it, it will like compute it whenever it needs. That is where persistent will come into picture. And whenever we are using the persist option, that is where we get these different storage levels. So if we specify the storage level as memory only, it is equivalent to cache only. So it will store the data into the memory of the executors. And in the memory there is another option which is underscore serialized. So by default it stores the deserialized objects in the JVM memory. So these are like fast, and these uses like a more memory when these are like deserialized. And if we serialize them, then it will occupy less memory. But while like reading the data, this will be slower because it will again need to like deserialize the data. So that is this option. And if we specify memory and disk, so whatever can fit into memory, it will store in memory. Rest it will store in disk. And with this also, there is by default it will be deserialized. There is serialized option also. And if you don't want to store anything in memory, then disk only is also there, where it will store everything in disk. Then memory only 2. So this 2, it is there for all these different options. So basically 2 means like it will store the same data, 2 replicas of it, so that if one is failed, it can use the other one. But practically we never use the 2 because it is just like a double storage, double memory it will need. And then there is this off heap is also there. It is experimental and advanced use. Normally we never use it. So these are all the different options we can use. So now you know, right? So cache, it is just a simple option which will store everything in the memory. And in most of the practical use cases, cache is enough. We normally don't use persist even. But in some cases, if memory is limited and if we want to store the things on disk, that is where memory and disk, or let's say disk only, these kind of options we can use. And practically we shall always try out the different options and we shall see how is the performance we are getting. And then for our use case, we shall decide which one is best for us. The next set of questions, these are about files. So normally we ask like what are all the file formats that you have worked with, and almost all the people, they will say like CSV, JSON, Parquet and Delta. So these are common formats that everybody has worked with. And we ask like what is the default format in Spark and why. So the default format in Spark, it is Delta, and Delta, it is built on top of Parquet. So what makes Parquet special, that it is the default format like the Delta, that it is a default format, and what all features are available that makes it the most efficient file format. And we also ask like what is a row and columnar format, because Parquet, it is a columnar format, CSV, it is a row format. So let's understand like how to answer all these questions. So first, CSV, I think everybody knows, like we have comma separated text files. But in Parquet, why it is so famous and so much used is due to its efficiency. So since it was founded in 2013 at Twitter and Cloudera, it has become like one of the best format even today. So this is a comparison by Databricks, like they used some data in CSV and same data in Parquet. So here we can see, right, CSV it used 1100 GB, Parquet it occupied just 2.5 GB. And while retrieving the data also, it was very, very fast and cost effective as compared to CSV. So what makes it so special that it is cost effective? That comes the next question. And also, what is a row and columnar format? So in a row format, the data, it is stored row by row. Like we have a CSV text file where we have like lines one by one, which are comma separated things, like shown here. Wherein in a columnar format, the data, it is not stored row by row, but column by column. So all these column values are stored together, all these are stored together like that. And why columnar is like more efficient? So while reading the data, let's say if we do select product and country from this table. So in case of row format, it cannot select just these two columns. It will have to read all the entire rows, entire columns. From there, it will pick up the required values because these all the things are stored together. Wherein in columnar format, it will be able to select just this and just this without reading the other column. That is what makes it so efficient. And this is efficiency it is getting only from columnar format, but there are other columnar formats also. So what make Parquet so special? So in Parquet, what additional things are there are the row groups and internal statistics. So because the data it can be so huge sometimes, so it cannot store the entire column also in a single file or single place. That is where it will create group of rows. So that is called as row groups. So let's say this file it has broken into 3 groups. Just for visualization it seems very like just 2 records, but actually it will be in thousands. So though in those row groups it will store all these single columns separately, all the single column values together. That is how it will store. So this is like one part, but the efficiency part lies in this footer part. So for all these row groups, for each of the column, it will store the metadata obviously, which is like the column name, data type and all. And along with that, it also stores the statistics details like what is the count and what is the min, max and distinct values for the numeric columns, how many null values are there. So those details are available in the footer part of the Parquet file itself. So let's say if I am trying to fetch the data where sales amount it is greater than 300. So if some file it has so many values, but values are not greater than 300, so you don't need to even read the file. It will just read the footer. In the footer it will see the min max value, and because the values are not in the range, so that file itself it will skip, and only the required files it will pick up. From there also only the required columns it will be able to pick up. So that is why it is so much efficient. And these are the things which are provided by the core Parquet format. Next comes like what is a delta format and why that is so much efficient. So delta format, it is built on top of Parquet files, and it provides some additional properties like time travel, ACID transactions and many more. So the delta itself can be a very big topic, but at least like let's cover that. Normally what I ask is that if we have created a delta table, if I go to that table location, so what kind of files I will find there. So let's have a look. This is one of the delta table that I have created, and if we look at this location, so these are the Parquet file in the main folder. These files they contain the real data, like the columnar data is a Parquet file that we just saw. So the extension it is Parquet, and before this Snappy, so this is the compression codec, the algorithm used to compress the file. So Snappy it is also old now. In Databricks the latest compression it is a G standard now, which is even more efficient than Snappy. So that is the new default format that has been set up. And along with these data files, the magic lies in this folder, which is the _delta log folder. In this folder, it contains all the transactions. So whatever operation we are doing on top of those that table, everything it is stored here as a transaction. And every transaction it will store like how many files are there, how many rows are there, which all columns are there, what are their max value, min value. So all these things, these are stored in these JSON transaction files. And this CRC, these are checksum file which ensure that the data in the JSON is not corrupted. This is its internal folder. Normally we don't see anything here, but I think while it is doing the transaction, some internal things it commits there. And these JSON files also, once it has so many files, like after 10 transaction or something, it will create a compressed Parquet file out of these transactions also, so that it can read these also efficiently. And now how delta is better than like Parquet, or additional feature it is providing on top of Parquet is due to this transaction logs. So now let's say if I fetch anything, let's say select star from this delta table and where some filter. So first it will not read even those Parquet file. It will just read these delta logs internally. from these logs itself, it has those min-max values. So it will know which all files to pick up, which all files to skip, and then it will be able to go and pick up only the required files. So that is how this delta formatted is so strong, and it is very, very efficient. Next, we are going to cover UDF, which is user defined function. So when we ask like what is a UDF, that is the part normally everybody is able to answer. Whenever we need to create our own custom function, that is where we define the UDF. But which language we shall use for defining the UDF, that part it is very important, and many people they don't know which is more efficient. And that is where we can write the UDF in Python also and Scala as well. But Scala, it is far more efficient than Python when it comes to UDF. And there is a very strong reason behind it. Let's understand. So this is our Spark architecture. And as I already explained, so the code that we write, that gets converted to Scala code. And that Scala code internally gets converted to Java virtual machine bytecode. And so on all the worker nodes, actually the Java code will run, JVM bytecode. So if we write our UDF in Scala, so in the worker there will no additional process. The same JVM will run that UDF code as well. So there is no additional overhead for this one. Wherein if we write our UDF in Python, so that UDF will not be converted to JVM, because Python does not run on JVM. Python runs on its own Python interpreter. So that is where to run our UDF, it will have to run a separate Python process on each of the worker nodes. And those will be two copies or two separate processes of the code, like one for the core Spark part as a JVM, second for Python interpreter. So because it has to run this as an additional process, and even when it comes to processing, Python is slower than Java. So that is why writing a UDF in Python, it is not recommended in Spark. We shall always write it in Scala. That is the best way. So now that we understand why we shall write it in Scala, let's understand how exactly we can write it. So here is an example. So first we define our function that we want to use as a UDF. This function, it can be anything. Let's say here I'm taking a string as input, and from that string I'm extracting the first number whatever is occurring there. So for example, here it is 5678, here it is 9821, here it is 45, like that. So basically the logic, it can be anything, it doesn't matter. But we define a core Scala function first, and that function we register in Spark, like this spark.udf.register, then name of our function, whatever name we want to give to the UDF, then the actual function here. So that is how we register our UDF in Spark, and then with this name we can directly use it, and we can use it even in PySpark. So we defined in Scala, we can use it in PySpark, and now you know why, because even this PySpark internally will be converted to Java bytecode. So this is how we use it in PySpark, and with this same name we can use it in SQL as well. So that's how we define, register, and then use UDFs. So these were the questions I wanted to cover here. I hope you got pretty good idea now what all questions are asked about Spark. And if you still have any doubts, any queries, please put them in the comment section. And if you liked the video, please put a like and comment on this video. Thank you. Bye bye.